everyone, my name is Su Yi. I'm a PhD student at the University of British Columbia, and today I will talk about how we use isolation techniques to ensure safe kernel extensibility with eBPF. eBPF lacks runtime memory safety. The implementation bugs in the eBPF verifier allows attackers to load malicious eBPF programs into the kernel. This allows attackers to gain arbitrary kernel memory access, such as overwriting kernel data and leaking kernel memory to the user space. Because the eBPF verifier is unsound, relying on static analysis alone is insufficient to guarantee runtime memory safety. Therefore, we implemented SafeBPF. It is a mechanism that dynamically sandboxes eBPF programs with software fault isolation and hardware-assisted memory tagging to enforce spatial memory safety at runtime. In SafeBPF, eBPF programs run in a sandbox, which is a region of memory that contains all the data an eBPF program can access. For software fault isolation, we generate two address masks for each sandbox, and we mask every load and store instructions so that when there is an out-of-bounds memory access, we can ensure that all memory accesses will always fall within the eBPF sandbox. Another isolation technique we implemented is memory tagging with ARM memory tagging extension, MTE. So memory tagging usually happens during memory allocation. And with ARM MTE, every 16 bytes of the physical memory is associated with a tag. During memory access, the hardware will check if the tag in the pointer matches the tag in the physical memory. If there is a tag mismatch, the kernel will raise an exception. And the way we use ARM MTE to sandbox the eBPF program is that we let the eBPF programs use a separate tag from the kernel, so that when the eBPF programs tries to perform an out-of-bounds access into the kernel memory, we are able to detect and prevent them at runtime. We evaluated SafeBPF on 7 high-severity vulnerabilities, and SafeBPF successfully prevents them. SafeBPF is also evaluated on web server macro benchmarks, and it incurs 0 to 4% overhead overall. The proceeding of this work will be available at the Cloud Computing Security Workshop 2024. And if you're interested in my work, you can contact me via my email. And we also have other eBPF projects available on my website. So for example, we've used eBPF to implement secure namespace kernel auditing for containers. And we've also used eBPF to customize prefetching policies in the Linux kernel. I'm open to collaborations, and I'm also looking for internships. So if you're interested in my work, please contact me. Thank you.